Okay. We're all set up. So welcome to the first stream of my multiplayer game dev. I have no idea how popular it will be. Um, so in this stream series, because yeah, it's a game, so it will not be finished for a long time. I will try to make my first multiplayer game. So and as well my first tank game. So that's the idea. A multiplayer tank battle with some cool fun things. And it will work on desktop and the browser at the beginning. We're using Java and LibGDX here. Um, and as you can see, I have nothing. And the server we will use is Node.js. Is a Node server, and we will use Socket.io to replay the events between everything. So first, let's name our game. I'm not really creative at the moment, so it will be just Battle Tank. You can always rename it later. Battle Tank game, and we need to have our create a new folder for the game. I'll create a new folder for the server, which we will implement as well. Good. We will as well select the tools, deselect box 2D. Eventually we want to implement controllers, but for now not yet. And I always like this UI, so save it. Let's see, offline mount is completely nope. We're just using plain Java and generate the project. So you see it's now generating, and we can see we have our game, and it generated our game. So I will use IntelliJ to open my project here, and I'll select the build. Then it knows it's a Gradle project, so it will now build all the stuff. Okay, it looks like everything is built. So we will first run the desktop launcher. We'll do a Gradle sync as well. And we run the desktop launcher. So we have our build configuration there. And as you can see, it cannot initialize this one, so we are using the wrong GDK. So I want to use GDK 15, but with the Oracle one, it's not working for some reason. So we use the Open GDK one, click Apply, and of course, source compatibility. 1.7, and we will replace this one to 1.15. Easy enough. So this will make it that we will be running Java 15. Why are we doing this? Well, just because we want we are not targeting Android or iOS at the moment, so we can just develop in that one. So if we now run it again, we will see here a nice game. Good. That's the default LibGDX one, so we are ready to develop it. I also like to use var. It's just the way I am. So we have config, set title. We also are using not the latest LWGGL. So let's see if we can fix this rather quick. Yeah. Okay, we will be able to fix it, so it's rather easy normally. If I can find it. It's in this one, so it's the root one, sorry. We will be putting 3. So we're in the last backend. Okay. Now this shouldn't be working. How will we now be doing this? So we'll create LWG normally should be creating this one, and we need that object. So var config. I don't know why IntelliJ is not working with me, but okay. Set title. And we set windowed mode to 720 at the moment. This should be configurable, of course, but okay. We set our config. Everything of this config should be eventually configurable. Let's see if we can run it. It's always the tricky part, and you see it's the same, but we're using the other backend here, the LWJGL3. And that's it for our desktop configuration at the moment. And we can jump right in. Good. This is our starting point in LibGDX. It's a game. And it extends the application up there to have the most easy code there is to display something. We will not do this. We will extend it. We'll extend game from it. We will as well delete everything in here at the moment and take in what we need. So we only need to create. And what the create needs to do is just set the screen. And we need, of course, to create this screen. And the first screen in a game will be, or it will be a splash screen to load in the assets for the menu. But we're not going to go in that just yet. We're going for quickly a result, so we will just start with the loading screen. And what I like to do is put every screen in a separate package called screen, and I as well also create an abstract class for it. So we'll create an abstract screen class, so of course abstract, and this one implements screen. Why do we do this? Because we can just override methods now and not implement them, and have the empty method bodies in our abstract class, so we don't pollute our code further. These are mainly for Android and iOS, these methods, so that's why we put them in here, because we're not targeting it just yet. We also want one protected value, and that's the battle tank game. We will always want the game object. So we say game, and of course we then need to insert the constructor where we get the game. Good, and so now we can go to our loading screen. Our loading screen will be in charge of loading the assets we need to display the game screen. So we as well will need to implement a lot. We will need to start doing loading assets and stuff. So if you have any questions when we're doing this, just ask it in the chat and I'll try to answer. So we have a loading screen, and we extend abstract screen from it. We still need to implement show, render, resize and dispose. And of course we need our constructor as well. So our loading screen, we will just make this one a fixed width and height, so we will put it in there. Static final int world width is 1280. Private static final int world, I have a typo, world height, and this one is 720 for us. And we want to show a progress bar, so we also have a width and a height for the progress bar. So private static final int progress bar width equals 1000, so we want it 1000 pixels wide. Private static final int progress bar height equals to 25. Easy enough so far. So how are we going to render our progress bar? It's with a shape renderer. So we need a shape renderer. We also need a viewport to display our shape renderer in. And we need, of course, a camera. So orthographic camera and we count camera. Then we have some state variables. So I'll call this one state. private float progress. So we need to track our progress. Private bool loading config. So if we need to load in config from the file system or so, we can have a bool to set this. And we have a started loading config. So to check if we already started loading our configurations or not. The constructor says as it is now. Then we need to set up everything. So that's happening in the show. So first we need to create our camera. And we set the position of our camera to our world width divided by 2 and our world height divided by 2, so it's in the center. And we create a 0. Of course it already says use a float man or we will lose precision, which is not something we want. And we after setting the position, of course, we need to update our camera. And we only need to update it once because the camera is not moving in the loading screen. Then we have, of course, a viewport, and we want to fill it. So we say fill viewport, world width, world height, and we give it our camera. And last but not least, we need a shape renderer to render our shapes. And here we need to create a list to load all the assets. And this list will grow when the project grows, of course. But for this, I like to use a nice utility class I wrote myself. I will write it again in the stream. But we see we still have a small issue here. We need to set our screen. We will do this, just new loading screen, and we posted this. And now we can compile our project again. Then for now we can close Battle Tank game. So here we should have our list of what we all need to load. And you have different things we can load in. So for this I like to create always a helper class. I will put it in the package utils and I call it Atlas utils. And this is a utility class, and for using a utility class there is a nice handy library. It's also for getters and setters, and it's called Lombok. So I will add Lombok to our project. So I will just copy paste it over, but in our build.gradle core normally. I don't see it. It changed. Dang. Okay, it's moved into this one. So in our dependencies for our core, okay, we have a new version. Of course we want a new version. Of course we want a new version. We have this one. So we say compile only Lombok, because Lombok is a compiler library. It will just compile it to normal Java behind the scenes, and a annotation processor because it only uses annotation. So the Atlas utils, we never want to be instantiating this one because it will only have static methods. So we will create a utility class for it. That's the nice thing about Lombok. We as well need to sync our Gradle. Good. So we will need to have a logging tag. I know Lombok has an annotation for this, but SLF4J is not really implemented in LibGDX. I need to find how we can make this work, but for this purpose it's not yet needed. So I will get the simple name of this class as our tag, and of course this will not change, so it can be final. What else do we need? We need private static final asset manager. We only need one, so we just instantiate it, and static resource. I really don't care about this warning. Yeah, we need to manage them properly. Just dispose them when needed. We will as well have a static method for this one. Private static final, and then we have an internal file handle resolver. That's something from LibGDX, and of course we create just an object of it. After that one, so our asset manager, we need to set loaders for it. So we have asset manager.set loader, and it's just making a registry of those class types and which loader to use. So for a tiled map, we use a TMX map loader. For a texture atlas, we will create a texture atlas loader, of course, and we need to pass it a file resolver. Which is fun. So we will have our first method. So public void unload asset. So it's possible that we need to unload assets when they're not needed anymore, or we only need, yeah, when the game becomes so big. This is a big one. So if the asset manager is loaded with the path, if it's not loaded, we just return. This is a coding style I like to use to quickly go out of the function. You could also say, okay, when it's loaded, do this. I like the other way around, especially when we need multiple lines below it. For most of these, it's not, but it's a coding style, and better to be the same. So we unload the path with the path, and then it's unloaded. What else do we need? We need a float, the load progress. And see, I said that every method would be static. I'm not typing static because the utility class annotation makes it static. So we say asset manager get progress, and that's the progress. We need a bool. We also need to, of course, update our asset manager. And we return this value. So this gives us if the update is correct or not. That's it. And then we have our helper methods to load in some stuff. So first we say void public void load map asset, and we say string path. Then we say if we cannot load this asset, we log an error with our tag, of course, and say cannot load asset from path with our path, and we return. So nothing gets loaded. Afterwards we need to say, okay, load this one, it's a path and it's a tiled map. And see, here we give our tiled map again. This maps to the loaders we defined here on top. So of course now we need to implement our private bool can we load. It's a path. So the path cannot be null and the path cannot be empty, and the asset manager is loaded. So it should not be loaded, and our file resolver can resolve this path. If everything is true here, we say okay, now we can load our asset in. This is an important part because else we have the possibility to load it twice, or we get a null pointer exception of some sort, so it's better to just cover it. So that's the load asset map asset, sorry. Then we have as well an atlas. So load atlas. Same here, we cover that we cannot load it. And return, otherwise we load it and we say texture atlas, so it maps to the loaders we set on top, and that's it. Then of course we need to get our assets as well, so we say public tiled map, we want a tiled map, get map asset. We need a string with a path. If it's not loaded, we are in an illegal state here, so we throw a new illegal state exception. The asset path is not loaded. We need to just stop here our game because, yeah, it will break otherwise, so it's needed to really throw an exception. Else we just return our asset manager dot get the path, and of course we need to cast it. And with generics, this takes care of for us. Sorry. Now we also have our load asset, so we need to say get atlas asset. The same check stays, but this becomes texture. Oh, texture atlas. And of course our return type needs to be changed. And this will just load in our atlases and our maps for us. We will be able to use this quite flexible. Oh. So back to our loading screen. At the moment we don't have anything to load in, because we don't have any map or atlas thingies yet. So for now we can leave it empty, but we will already be implementing the rest of the logic here. So in render, so that's the update method that always gets called. We say asset utils. Oh, I called it atlas. Ah, oh, that's not smart. Ah. Assets. Utils. Asset utils dot update loading and start loading config. The config is for later on when we need to load in config files, and that are not assets. And we say when everything is loaded, and the update loading will always return files until everything is loaded. We set it to 90% here, so the last 10% is for our configurations to load. So we say started true, and then load configs. That's a private method, we will just create it here. it's also something we will be able to use later on. And here we say load progress. So we get our load progress. If, and of course the last thing of our load progress, we need to say done loading config is true. If we are done loading our config, yes, then we can say game dot set screen, because it's public, new main game screen, and we pass it game, of course. Let's create this one already. This extends, of course, abstract screen. We need to call our super and implement some methods, and that's when our game starts. So you see, we load everything in, then we load our configs, and when the configs are loaded, we say okay, we go to the main game screen. Now the actually rendering stuff. So we say screen utils dot clear, and we give it a color 0001, so it's just black, and we say shape renderer dot set projection matrix camera dot projection, shape renderer dot set transform matrix camera dot view, shape renderer dot begin. We want a filled shape, shape renderer dot end, and we start with a color. So we say shape render dot set color. We want white. Shape render dot rect, and here we say our world width divided by 2f minus our progress bar width. That's our start. Then we want it in center, so we say world height divided by 2f minus, of course, our progress bar height divided by 2 float. Okay, then we want our width, so progress dot times progress bar width, so it's the percentages, and we always want our full height, of course. And now, and I can show you this. So if we set a screen clear, a screen utils dot clear, we give it the color green, we will see eventually a green screen. Lol. Done. And why is it immediately? Well, we're not loading in anything yet, so this is fine. I will as well put it to black to start with the black screen. Good. But not everything here is done. We still have some methods to attend to. We want here in our resize just viewport dot update width and height. And in our dispose we say shape renderer dispose, because we're not needing it anymore. Now we're ready to really start working on our game. We will start with just moving cubes around. That's the easiest to see if our networking works. Hey Alex, how are you doing today? If you have any questions about what we are doing here, just tell them in the chat, and I'll try to answer them as good as I can. Good. So, first of all, what we want in our game is that every user as well sees the same. So, if they have a bigger screen, they will see the same area, or it would be a bit unfair in a multiplayer if you see more. So, we have a static final int called viewport width, and it's again 1280, and we of course have our height, and our viewport height is 720. There is some stuff we always need in our games, in our game screen. So we will need a camera again, but this time it will move. We need a viewport. We will need a sprite batch to draw everything. We will also need a shape renderer again. Yeah, probably. I'm not a fan of it, but maybe we'll just add a quickly a tank asset. Maybe we'll do that. We will also have an input multiplexer, because we will have UI and the player input. So we also have an input manager, which we will need to create. That's something from us. And of course we will start with a player. Okay, so the first step we want to do in our game is just move something around on the screen. We will have a player class for this one. And the player class, so we will have multiple players. So we have a player that's actually playing, and we will have other players over the network. So it will be difficult. Yeah, so I said I also didn't, I never did it, so it's a bit of a journey for both of us. But okay, well, we'll just tackle it head on, and we say create in the entity a player class. We'll see where we need to tweak to make every networking stuff work. We'll handle it. So let's first see what assets we will use. So I found some assets from Kenny. So Kenny has top-down tanks, so this is already a nice one for us. Kenny has a lot of free stuff, items, tower defense stuff, so maybe we can use missiles or some sort voxel stuff, other tankies, smoke, which we will certainly need, other sort of tanks. I think we'll start with this one and see where this one gets us so far. So if you want to donate to Kenny, there's a lot of great assets. Donate or become a patron, or just don't. That's of course totally up to you. Good. Let's see how he pegs this. So this is really nice to use as a map already. And this is our sprite sheets, all sprites default. That's nice. But I'm going to use a small tool from LibGDX As you can see, we also have here everything separate. I will use the texture packer or LibGDX to do this, so I will as well create a new module in my IntelliJ. So let's create a new module. Of course, it's a Gradle module, Java, next. And this is our texture packer. This will not be included in the game, it's just a tool to help us develop some stuff. And it creates a build.gradle. So, I will just copy paste it in from my other project because I already did it once and I'm not a real hero with Gradle just yet. And I hope this error is not really something to keep into account. So what do we want to do now? As you saw, I lost it. We have here a whole list of tanks and body and tiles apparently that we need to filter out. So in here we will create a new folder called assets, and we will create a new directory in assets called tanks. So in here we will have all our assets for our tanks. So we will show this in not find, we want to show. Open in files. So first of all we're just going to put everything in here. Okay. As you can see, we have way too much at the moment. It's bullets. We don't want bullets. Great, not yet. We just want our tanks. That's all terrain. Well, we can keep the wire. We want the tracks still. We will keep the rest. So this is tanks and some barricade stuff. Maybe not. I think I'm going to pull out the bullets already and put it in a new folder called bullets, because our yeah, sprite sheet can only be X amount big, so we want to have, we don't want too much in our folder. So we want the explosion as well with bullets, or not, or do we want to create an effect? Of course, this is as well with the bullets. This shot is with the bullets. No, it's also effects. We will create an effects one. Effects. So we have our explosion. We want in effects. And of course our shots. Our shots. What else is in here? So these are barrels, crates, barricades, crates, Sandbag, fencing, that's all tank stuff. Okay, so we will create one last thing. And well, we'll call it environment items because it's not really items that we can pick up or so. That will not be the point. But I want them out of here and somewhere. So these two. Keep those in tanks. Those are wires. Maybe we can show it when it's damaged or so. How many wires we show? I don't know. I never use the texture pack as well, so everything is just a journey for you and me. So with blue, a big tank. Well, we can develop some fun stuff with this, I think. Yeah. So now we have multiple assets loaded in. Of course, we want something to load. We want to create our textures. So I will just create a new class. And it's just a small tool for us to use to pack our assets. And we will use LibGDX tools for this. So we have a settings object. And this settings object comes from the texture packer. Of course, no. And that's already a good start. So now we will set the settings of every pack we have. We say it a max width 2048, and same with the height. That's the highest we can really go if we ever want to target mobile. You don't want to rotate. We want to duplicate the padding. We don't want edge padding. And our padding X is 0. And the padding Y is also 0. Good. Now the lines we need. So we say texture packer dot process. We need to pass the settings, our input. So we have assets, tanks, and it's a whole folder. And then we have an output. So we are in this folder in our project. So our output is we go out of this one. I think because we can set a working directory. Okay. Yeah. So core assets. Then we say packs, tanks, and then the file name of the atlas is tanks.atlas. And then we can print out done packing tank assets. And of course you want to do this for the rest of our assets as well. So we have bullets. We want to put this in bullets and we call it bullets. we do it the same for effects, and of course, I made typo. Environment items, and we can run this one. Maybe not. We need to set a working directory. So our working directory is our texture packer. Now it will run. Tab K Gradle feature, blah 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 blah, making it compatible with 7. I don't know what it says. I need to look into it. So now you can see that it wrote some stuff, and how big the files are. And then here you can see that it's created. We can open the atlas of the tanks. So now LibGDX, we have a LibGDX atlas, which helps. Yeah. And yeah, you can see how it's spec'd. We can control it further with the settings and stuff, but it's okay for now. The files are not too big. It has a max width and a height. So if it's in those constraints, it's just fine. Of course, we already have some assets now, so we can open our loading screen again. And then where we said, okay, we need to load it, so we say asset utils dot load atlas, because we created atlas asset, and this is one packs characters atlas. I'm just typing it over of my example project, game. So it's of course tanks. Characters will maybe need bullets. Effects. Environment. It's a difficult word. Items. I'll just copy paste it. Boosh. So let's run it again, our game, see if everything still works. Maybe we made an issue in our asset utils or so. And you could briefly see the loading screen. So this as well is not correct. We want to do it like this. So we want to know what our padding is, and then we divide it, and that's it. Yeah. Okay. Nice. We have assets. So our player will be a tank. But the player will be playable of this computer. So we will need to make a difference between the player tank and just tanks in general. So I will rename it two-player tank, and we will refactor this one. So we're going to use polymorphism here. So I will as well start with an abstract class called entity to have the most basic stuff in there. So it's an abstract class, and this one implements disposable. So we can dispose our class when needed. So our entity, I know LibGDX has a sprite class. I don't really like to use it as yeah, it it's too cluttered. Let's say it like that. I like it a bit more clean. So we will have a vector current position. We have a protected vector next position. Vector velocity. Direction, which we will need to create. And this is a bool. Directions is just an item, so I will create it. It's an item. And it's just left, right, up and down. And that's it for now. And this needs to be an object as well, so put it like that. After that we have a protected texture region, current frame. So we have a texture that we can draw. Then some physics stuff. So we have a rectangle, and we call it bounding box. Rectangle. Next position, bounding box. So we can do collision detection up front. And that's it at the moment. Then we will as well have a constructor, and it's protected. And for the moment we don't put anything in. We will put a map manager in there in the future when we have our tiled map. Now we just start initializing everything, because we're not moving yet. And once we have a tank moving on the screen, just up, down, left, right, how it should be turned, I keep it in the middle just yet, and how we will move. For now it will be just fine. next bounding box position is also an empty rectangle. Well, just a rectangle, sorry, not empty. And then we of course need to create our directions hash map. And then we need to put in our directions. So why have we a hash map for this? This is so we can map everything at the same time and just check it. So we can go right and left at the same time, so we will be stuck in the middle. But if you go up and left, for example, we will go diagonal. So that's a bit the point at the moment. It could be that we tweak it later on. I don't know yet. Then our abstract methods are update, and we have a draw, which expects a sprite match to draw it. Then some helper methods that we want our entities to have. So init bounding box, it's a width and height. Bounding box dot width equals width. Bounding box dot height. So yeah, this is a bit the boring part of the game that we need to set up before we have something. But once we have something, yeah, it becomes real fun and you can start playing a little bit, and every extra you add is a bit more fun. And now we have another method, update bounding box. It's important method, this one. The reason we make it protected is because we want to be able to call it from the other ones as well. So update bounding box. Bounding box.x equals current position. Bounding box.y equals current position.y. So that's the update bounding box. We have an update next position bounding box, also needed. So next position bounding box dot x equals next position dot x, next position bounding box y equals next position dot y. And we spend a lot of time on developing a bit of a system with polymorphism, so we can save time in the future and develop it and extend it more easily. So we set our next position to the current when we call this. So current position dot set is then next position. I have this bit of a real good book I read about LibGDX some years ago, and it's called Mastering LibGDX. So if you're really interested in LibGDX, go read that book. It really helped me. And of course we need, when we update the position, we need to update the bounding box as well. So next up we will start calculating the next position, and this is also in the entity, because if you want AI we can as well sync it with this one. But the AI should be controlled by the server then, because it's wow. Yeah, like I said, I did not really create a multiplayer game yet, so we will see how we will tackle it. Float delta. So first things first, our next position is our current position. Then we have a velocity and we scale it down with our delta, And to not forget it, I already do this now. We then scale it back up with the reverse. So we divide 1 through delta. This is the reverse of it, so our velocity is again what we set it. This makes debugging way more easier later on, but we just need to stick it. So then it's a bunch of if statements. So we check if directions.get left. So we check if it's true, and if it's true, we say next position.x minus equals velocity.x. It's not more than that. Quite boring code, to be honest, but this will take care of the movement of our entities. Right, we say we go up, we copy the whole thingy here. Then if we go up, well, let's go down first because that's the minus. Of course, we then need to change the x with the y. And if we go up, it's a plus, so we put 2 times y, and that's done. This will calculate our next position. But, you see, how will we do the collision checking? That's a good one. We have our update bounding box. Next position bounding box, so we need to update that one as well. Also rather important. Yeah, guys, so if you have questions, please put them in the chat. I like to answer all the questions you have about what I'm doing or how I'm doing it. Or if you have suggestions to make it better, please say so. I'm always open to learn some new stuff. So this is something we will need to implement later on. We don't have a map yet, so it's not possible. So we will put a to-do there. And this one will just check, are we in collision with the map or not? We will also have something, are we in collision with an entity or something like that. Then we cannot move. Okay, great. That's it for our abstract entity. Nice. So our player then can extend our entity. And of course we need to implement some methods. Update, draw and dispose. So eventually I think that the draw will be mainly inside another abstract in another class, tank. That player tank extends, but for now we will just try to create one player in single player to drive around because we want something on the screen that's more fun than a black screen. So we will need an input manager as well. Yeah. Let's see. We will go with input manager. So I like to create games with a whole bunch of managers that manages one thing. So we have a projectile manager, we have a network manager we will have, and we of course have an input manager. So we can handle the inputs. We will create an inner enum input type. It's a keyboard and controller. Nice. And of course input action. So This is our actions we can have. Uh, Later on we can use these enums to map it with the config and stuff as well, so the keys are configurable and all that good stuff. So we have left, we have right, we have up, we have down, the same as directions, and of course we have fire. We have an input type, current input type. We have a private keyboard input processor, which we will need to create. And we have, that's something as well, we need to create private abstract input processor. And that's the current one. And to be thinking, I don't think we need this one, I just need the current input processor. So again, abstract classes, yeah. It happens that it's always with abstract classes. We create a package called input. I will move this one as well. We will start with the abstract input processor. It's not so difficult to implement. Okay, of course an abstract class. What else? What will this class have? This class has a protected map. It has an input action. And are we using these input actions at the moment? Our constructor then. Create a hash map for this one. False. So we put everything false. We have right, we have up, we have down, and we have fire. One too much. Then we have a helper method, so public boolean get input action, and it's an input action, and they just return it should contain the action and get action. Easy enough. And we have as well an abstract method. Get mouse position. It's a bit of a bad word. Yeah, yeah. I'm thinking that we want to drive where we are pointing with our mouse to make it a fast-paced game. So we want to rotate to the mouse too, because it's top down. Yeah, I I have I don't know how to call it with crosshair position. I don't know. I don't know how to tackle it with controllers just yet. But now we need to implement this abstract input processor at least once. And we will use our keyboard for it. So it extends the abstract one. And of course we need to have the get mouse position. We have a private vector2 mouse position. And this one will then just give the mouse position back. So we need to initialize the mouse position as well. And then you need to implement the input processor. And that's where we implement our keys and stuff, and touch and drag and scroll and all that good stuff. I will just copy paste a bit of code because it's real boring stuff. So in contrast of what you have been doing, we only want one key per cycle to be processed. Yeah. We set it false. We set it true when the key is down, and we set it false when the key is up. So that's nice. And then when we touch down, we are firing. So that's also just an easy if statement, and when it's touches up, then we are not firing anymore. And you see, we now hardwired it to the keyboard and what keys it are, but we should create. We should really create a config eventually for it. And then our last thing we need to implement is our mouse moved, and here we say mouse position dot set, not scale, set screen X and screen Y. Okay, so that's that. So now we have one input processor, but we have the framework to extend it to controllers, to do, I don't know what, mind control if you want, and control it. I don't know what the future will hold, but it's possible. So we go back to our input manager. Create a constructor for it. We say current input type is keyboard, and then we say current input processor equals a new keyboard input processor. And now some helper functions. So we say public boolean. We don't want to directly go to our abstract input processor, but the input manager manages it, and we have some methods that we should use to in our entity. So is moving in direction. Now we have direction. And now we can have the fun, cool new switch statement in Java. So case up. We say get input action up. Same for down, left, and right. So no breaks and stuff anymore. I really like the new switch of Java. Then we have public bool is shooting, and then we return our current input processor dot input action fire. Is shooting released is another one we need to do, and it's just the inverse. And then we have, of course, our public vector to get mouse position. Get mouse position. Nice. Okay. So that's our input manager. I'm going to take a small break of 2 minutes to fetch me some new drinks. I'll be right back. Okay, I'm back. Okay, back to our player. So our player has an input manager. Okay. We start with the constructor. Player tank. Pa-pa-pum. And we pass it an input manager. Our game screen needs to take care of the initialization of this one. So we call super. And then we say is input manager equals input manager. We say init our bounding box to let's see how big our things are. So our large tank is how big? 52 by 60, and our just sand body properties is 40 by 40. That's Okay. So yeah, I guess that we'll use it as is, so 42 by 42, and that will be our bounding box. And this is a bit higher even. Okay, but that's normal because that's behind the tank. Okay, so let's say our tank is just 42 by 42 at the moment. We can play with the numbers later on. We will as well need to set our current frame, so we will say um, how will we be doing it? We'll create a private method for it, load texture. It's a bit better, and we'll as well need to set a velocity. We'll put it at 200 each. Yes. Of course, need to update our bounding box and update our next position bounding box, and that's it at the moment. Yeah, I think so. So we need to implement our load texture. So private void load texture. Go for it. Var tank atlas set utils dot get atlas specs tanks dot atlas. What we should do is create a class with all those names in there, but for now it's okay. This will never be null because we say if it's not loaded, throw an exception, so no need to check this. But we say current frame equals tank atlas dot find region, and now we need a name, and those are in, it's based on the file names. So because now we just want to put it on display. We will go with this poly, with the blue one. Yeah. And that should do it. Of course, we can as well do this. How does it look? We don't really need a variable over there. It's also fine. Now we don't need the method. It's a bit overkill, apparently. Boom. Done. So now we have a current frame. But of course, we need to spawn the player somewhere. So, yeah. So create a method for it. later on I want this to be on the map, so the map will have positions where a player can spawn, and we will just spawn because we will have a lobby of let's say 10 people, and then spawn those 10 people randomly, I guess. Yeah, something like that. Gameplay needs to be still worked on. I just like the code, so that's why I'm doing this. So private voice set player spawn, and for now we will say no current position for spawn position equals new vector 2 150 150. Then current position equals spawn position dot copy, and next position as well. So that's that. Nice. What's next? Implementing the update method. So what will we need to update? We need to update the movement. And that's it at the moment. No. Update camera. Yeah, so we need to update our camera as well. So first things first, update the movement. Private void, update movement float delta. So directions dot put. Then we have left, and of course our input manager dot is moving in that direction, direction dot left, and that's our value. So here we can see our translation layer between the entity and movement and our input. We have right, down and up. So here it's up, down and right. Okay. If is collision with map, set next position to current. Body. That's not needed, sorry. Okay. Yeah. And here we say calculate next position with our delta. So here we set our directions. Then we say, are we in collision with the map? So it will check the next position. If you're not in collision, okay, set the next position to the current, and you can calculate the next position again. If it's not, we do not want to change our we do not want to change our position, but we want to calculate the new X1, because if we, for example, the wall is up and we cannot go up, and we press down, so we need to check it again. That's important, else we soft lock. Then we need a camera, and because we do not have a map manager, but the camera is on the, we will for now we will put the camera by the player as well. Normally the map manager is in charge of the camera. We can refactor it out later on. So private void the camera. Why do we need the current positions? So later on, when we reach the edge of the map, we don't want it to see uh, a black bar, but we want to keep the map still and only and don't not move the camera anymore. So for now, we can just say camera dot position dot x equals x, camera position dot y equals y, and we say camera dot update. Pa-pa-pa-pum. That's it. Can make it final. We should make it final. Boosh. Next up, our draw method. And that's an easy one in this case because we don't have any animation yet. We say batch dot draw current frame current position dot x divided minus width current frame dot get region width 2f, and we will copy this for the y as well. Y and get region height. Yes. I think that's it. This pose we can leave it open for now. Back to our main screen then. We can comment in our input processor. In show. So we have a camera, so we say new orthographic camera. We have a viewport, we say extended viewport, port width, viewport height. We give it the camera. Then we have a sprite batch. We're just creating one. We will load one from the map manager as well. Yeah. The tiled map renderer gives as well a sprite batch. We have an input manager, so we instantiate the input manager. And then we say player tank equals no player tank, input manager and camera. We have an input multiplexer equals no input multiplexer to do hit UI first. And then we say input multiplexer dot add processor. We say input manager dot get current. So we need to implement a getter. And we cast it. Yes, we can. And then we say GDX dot input dot set input processor input multiplexer. And I think that if we put in player tank dot update delta render begin sprite better dot end player tank dot draw sprite batch that we are now rendering everything we need to do. Only thing it's left to do is here viewport dot update with height. Nice. Yeah, so now we should be able to move around. Let's see. Look at this. Beautiful. Can of course still go outside. Yeah. Worked great. I'm as well going to do one small thing. GDX dot graphics dot set title. GDX dot graphics dot get frames per second FPS. So we can see our FPS as well in the title, which is always nice. And we can immediately spot frame drops. And as you can see, it runs smooth 60, 61 FPS, which is capped at. So we did good. Good first start. So that's only took us 1 hour and 40 minutes. But this means that we can start working on multiplayer stuff as well. Good. Yeah, I think we're all set to start working on multiplayer stuff, and I think I will start doing this in the evening in a few hours once dinner is done. So yeah, I hope to see some of you back. I don't know how many people were watching, but it's always fun to share the knowledge we have. So